Hello guys, and welcome to my channel. Now in this video, I want to talk about the Cartesian product. Okay, so we said that the Cartesian product, which is denoted by A cross B, that is the Cartesian product of sets. Okay, so if you have set A and set B, so the Cartesian product of the two sets is denoted by this. Okay, just use the cross product like that. So the Cartesian product denoted by A cross B of two sets A and B is a set of all ordered pairs. Alright, this is how you write it: small little a and little b. Now, with the first element, the little a, chosen from the set A, and the second element, the little b, chosen from set B. So when you take the cross product, okay, or the Cartesian product of two sets, alright, like this, then it follows that we are going to be having a set of ordered pairs. Now, the ordered pairs is such that the first entry is an element from the set A and the second is an element from the set B. Okay, so this is pretty simple according to the definition, and I'm going to give you an example to illustrate what I'm actually talking about. Alright? Okay, so we are saying that the definition as a whole can be rewritten as the cross product of the set A and B to be given as, now this is a set notation, we can use the set builder method, this is what I'm making use of. Now it is equal to the ordered pair A comma B. Alright, now the first element here belongs to A, okay, is an element of the set A, while the second element is an element of the set B. Alright, so that is just it. There's nothing different about this. Okay, so let me go ahead and clean a part of this so that I show you guys an example on this. Okay, here we have a very simple example. It's example number 1, so I'm going to do the second one for you guys. Now, if A is equal to ABC, okay, it contains element ABC, and B contains some element DE, alright? So you see that the sets A and set B are different because they contain different elements, and they are not even equivalent because the cardinality are not the same. Okay, so let me just say this real quick. Equivalence of sets shows that two sets have the same cardinality. Alright, so two sets are equivalent when they contain the same number of elements, not the same element, but the same number of elements. If this one contains 3 elements, this one contains also 3 elements, it could be distinct. It means that the two sets are equivalent. Okay, so for equality, they must contain exactly the same element. Alright, that's by the way. So here we have to find A cross B. Okay, so from the definition we just had, it's going to give to us that A cross B is equal to, now from the statement we take the first element from the set A and the second element from the set B in the set of ordered pairs. So this is how we are going to write it. Okay, if you recall in the definition we were having something like a bracket AB, and a statement before that was a set of ordered pairs like this. So this is how we are going to put it. Take the first element from A, take the second element from the set B, that will be A comma D. That is the first ordered pairs. You put a comma, take the first element from A, you continue with the letter A until we are done with it, alright? So that will be A comma E. This is the next element. So the next thing will continue with B. You've already taken A comma D, A comma E. The next thing B comma D, B comma E, C comma D, C comma E. Just like that, alright? So that will be B comma D. So the next thing is to, let me continue here. That will be B and E, alright, taken together, and the next thing will be C and D taken together, and finally C and E taken together. Alright, so just like saying 6 elements, right? 1, 2, 3, 4, 5, 6. Okay, so that is more about it. Alright, okay, so that's pretty simple. Okay, let's move on to the second example. And here, as you can see, in the second example, we are given only the set A, that if A is equals to ABC, alright? I'm just using that. Now, the idea I want to share with you is that we are to find A cross A, alright? Just a set, Cartesian product of a single set, that is a set with itself. So we are still going to do this the same way, it's nothing different, alright? So all we need to do is to know that since A is equal to this, then this A, right? This other A here is not going to be different. It will still be the same thing. For example, they say you should cross it A cross A. So let me just write this one out. A B, C. So since we are writing A cross A, just want to do that. So all we need to do is to go ahead and compute that. So A cross A will now be equal to, still making a mistake. A cross A will now be equal to, now here we go, the first element from the first set and the first element from the second set to form a Cartesian, to form the ordered base. So we're having A comma A, right? In order, that's what we're taking first, A, B, right? So take it again, A comma B, right? A, C. Okay, so that's pretty simple, right? A, B, A, C. Okay, so the next thing we like to do is to enter with the B, A. So it doesn't matter whether it's alphabetically. All that matters is where is the first entry from. It's from the first set. The second entry is from the second set. That's all that matters, right? The next thing we do is B, and then B, C. So we continue like that. C, A, right? C, B, and then lastly C. Let me clean this. C. Okay, so that is it, and you remember to close that. Okay. So that's pretty simple. Alright, so you go ahead and subscribe to my channel, alright? And you can go ahead and solve other problems on this. Okay, thanks for watching.